Understanding motion. Motion is relative to the position of the observer. For example, you can see that an automobile is moving with respect to the ground. Different observers may perceive the motion of an object in an entirely different way. Or we can say that an object is in motion if its position changes with respect to an observer. A rocking chair, a swing, a bouncing ball are the examples of things that assist motion. The Earth in its orbit around the Sun is also said to be in motion. Motion along a straight line. Everything in our world moves. Even stationary things such as your house move in relation to the sun or to the other stars. The motion may be purely vertical, that of a falling stone, purely horizontal, that of a car on a level highway, or slanted, that of an airplane rising at an angle from a runway, but it must be a straight line. When we try to locate an object in physics, we will usually relate it to some sort of reference point. This point is usually the origin, the 0 point of an axis, x, y, or z. Furthermore, we provide a numeric representation for an object's location by placing it either in the positive direction or negative direction in relation to that reference point. For example, let's put a particle at x is equal to 0 meters. The particle would then be located at 10 meters from the origin on the x-axis. As you may have noticed, position is marked by some unit of length. The typical unit we will use is meters. Here the distance covered by the object is 10 meters. To describe distance, we need to specify only the numerical value and not the direction of motion. The numerical value of a physical quantity is its magnitude. The difference between an object's starting position and final position after it moves is known as displacement.